Assalamu alaikum, my friends. Peace be unto you. This is Rusty Waller in the Teaching and Learning Center at American University of Ras Al Khaimah. We're continuing our journey in studying confidence intervals, and in this particular video, we will look at establishing boundaries or identifying the boundaries in a raw data problem that would trap a certain percentage of data. You will recall from our previous lectures this exciting little table here, confidence interval critical values of Z sub C. In other words, we looked at 70% confidence all the way down to 99% confidence and observed that these are the Z critical values. For instance, between negative 1.04 and positive 1.04, we trap 70%. Between negative 1.645 and positive 1.645, we trap 90% and so forth. So we're going to look at a real life problem applying this particular table to establish a confidence interval for raw data values. Now, here's our problem. A population of penguins has a mean life of 5.4 years with a standard deviation of 1.1 years. Establish a 95% confidence interval for the lifespans of this population. Now, in order to do a problem like this, we need to establish some steps. Always determine what the problem wants you to do. Read for meaningful information. Now, we see that this problem is about establishing a confidence interval, so we're going to draw the picture and mark the z-scores, and then we're going to convert the z-score boundaries to raw data. 4 simple steps. Now, bear with me. I'm going to walk you through these steps in this program or this particular problem so that you can solve it fairly easily and you can replicate it with other problems. Now, the first thing we do is determine what the problem wants you to do. It wants us to establish a 95% confidence interval for the lifespans of this population. Now, it's important that we notice that it's 95% confidence interval. It's also important that we notice that it is for the raw data values, the lifespans. In a little while, or in a couple of lessons, we will be determining whether it's raw data or perhaps an X-bar distribution that we're looking for. But we start out with raw data. Establish a 95% confidence interval. The next thing we do is read it for meaningful information. The population of penguins has a mean lifespan of 5.4 years. That's the mean, with a standard deviation of 1.1. Now, you notice we used mu and sigma rather than X bar and S. The reason being that it says a population. We're not doing a sample, we're examining a population. So we want a 95% confidence interval with a mean of 5.4 and a standard deviation of 1.1. Now we need to draw the picture and mark the z-scores. Well, we draw the pictures of the standard normal curve, but we don't yet know which z-scores to mark, but we know we have a 95% confidence interval, so let's go to that particular table. And we read down for 95%, and when we get to 95%, we find 1.96. So our z-scores are going to be 1.96 and negative 1.96. Remember that those critical values are equally balanced on the mean, and together they trap 95% of the data in this range. So we're almost done. The last thing we will do is convert the z-score boundaries, these are boundaries, to raw data. So we're going to have to convert these data to raw data values so that we know what age lengths that we have 95% of the population lifespans trapped between. So let's look at the two boundaries. Go back. A population of penguins has a mean lifespan of 5.4 years with a standard deviation of 1.1 years. Establish a 95% confidence interval for the lifespans of this population. The two boundaries are Z1 and Z2. Here's Z1, here's Z2. And remember that a Z-score is found with this formula. X minus the mean divided by the standard deviation. The data minus the mean divided by the standard deviation. In this case, we're trying to trap the data. We know the z-score, it's here. We know the mean, it's here. And we know the standard deviation. So let's plug those values into the two formulas, and then we will simplify for x. Negative 1.96, that's z1, equals x minus 5.4 divided by 1.1, and 1.96, this z-score, is equal to x minus the mean, 5.4, divided by the standard deviation. The first thing we will do here is we'll multiply both sides by 1.1, And when we do that, we now have negative 2.156 equals x minus 5.4, and 2.156 equals x minus 5.4. Now we're going to add 5.4 to both sides, and we come up with 3.244 and 7.556 are equal to x. So we know that 95% of the lifespans are between 3.244 years and 7.556 years. Now, that really wasn't very hard. I want you to notice again, all you did, you determined what the problem wanted you to do, you read for meaningful information, you drew the picture, and you marked the z-scores, and then you converted the z-scores, the boundaries, to raw data values. And we did that by plugging in the values and just doing a little simple algebra, and there we went. And now we know that a population of penguins with a mean lifespan of 5.4 years and a standard deviation of 1.1 years, that 95% of the lifespans fall between 3.244 years and 7.556 years. Now keep in mind again, this was a confidence interval for raw data, for the lifespans, not any averages or anything else like that. We will do those later. But it really isn't very hard. These are very simple problems as you work through them. And I want to encourage you, because by learning this one step at a time, you will walk up a great stairway to where you gain knowledge and can do some really awesome things. Just in closing, I want to thank you for your support. It's your patronage that keeps my family fed. And again, in the mantra of the Hunger Games, one of my favorite movies, may the odds be ever in your favor. You have a great day.